بسم الله والسلام عليكم ورحمة الله وبركاته. Hello everyone. Almost 2 weeks for the exam. So I hope things are okay. Most of you have finished the exams and the finals and everything is cool. So I think that's now only the time for the AP chemistry exam to come, inshallah. So these 2 weeks are the most important weeks. So if you studied very well through the year, or if you studied half, or if you are planning to do most of your focused work on the next 2 weeks, you still have time even to score 5. And guess what? If you just focus on very small points, then it will be very easy to get the 5, inshallah. So the AP chemistry exam is a big material. I cannot say that you can study everything and be like the student who studied from day one in the school. يعني I will be just like زي ما بيقولوا بالعربي وأجحف حق الإنسان اللي جات الأيام. So but still you can make the 5 if you just focus on the important points. So let's share the website and see some of the questions that might be important or the points that might be very important in the exam. And I hope you can see the website already. The website is designed so that you can try when you are a little bit lost to find what is to guide you or what is to help you or what's to find the things that are important. And for the time being, for the next 2 weeks, I recommend you focus on 2 important parts. The first part is the hard topics check, the exam month self-check, and the top 10 most asked questions. So if you try to Google the questions, or if you try to find what are the most important parts, you will spend some time. So I try to make it easier for you. It's just I collect the questions which are most asked. I went through the social media, I went through the Reddit, I went through the websites, and I tried to see what are the most important questions that always the students ask about before the exam. So I found out that most of the students ask about 10 important points, and I added to them 2 points in which they don't ask, but I feel that they always have a problem with. So either it is the questions are directly asked, so some of the students said I need to have a little bit stress on the buffer capacity, on the notation of electrochemical cell, or it is some parts that are usually missed. So let's have a look how it looks like and hope that works well. So let's look at the formal charge rescue plan. So just if you don't remember, or if you remember, let's revise together. The formal charge is just the valency electrons, the number of electrons in the outermost shell of the atom, and it's always calculated from the group number. So if you are in group 6, you can find that you have 6 valence electrons. If you are in group 2, you have 2 valence electrons. Then you have the lone pairs, and the lone pairs are how many electrons which are not making any bond pairs, and they will count them. Is the atom which we are talking about having one lone pair or 2 or more, and then half the number of the bonding electrons. So if this atom has 4 bonding electrons around it, or 8 bonding electrons, or 2, or whatever bonding electrons, then I will just divide it by half. Then I will just subtract this from the addition of this, and then I will find my number of formal charge. And the most important rule, which are always confusing the students, if I have atoms have the same formal charge, like I have 2 atoms or 2 structures, structure A and structure B, and he asks me which one of them is the one which has less formal charge, so you can decide which structure is the most stable. Then when I calculate, I find that both of them, or all structures given, have the same formal charge. Then I have to give the negative formal charge to the most electronegative atom. So I will look, where is my most electronegative atom? If I found it, then I will say that this one should be the negative formal charge. This one should be the least formal charge. Okay, what are the most 3 general mistakes which happen in the formal charge? The first one is using total electrons instead of pair atom valency. So I will just count all the electrons, and believe me, this happens a lot. Some of you who knows how to calculate the formal charge will tell me how this is happening. Yes, it's happening. I see this all the time. People are just putting all the electrons instead of the valence electrons. for getting lone pairs, you have to not forget the lone pairs and putting the negative formal charge on the wrong atom. So if I see C and O, I see some of the students for no reason, they don't know the rule, they don't know that it should be the oxygen because it is the more electronegative. So they pick the carbon instead of the oxygen. So they get confused. They look at the two structures, found they have the same formal charge, so they don't know what to do, so they just pick any one. So for example, they pick the carbon instead of the oxygen. So for example, I have low structure here, and I need to find which one is more stable. So I have two versions of the OCN. And both of them, I will have the formal charge is equal to 0. So I will check the formal charge of oxygen is 0. The formal charge of carbon is 0. The formal charge of nitrogen is equal to 0. And then I will do here, I'll find the formal charge of oxygen equal to -1. The formal charge of carbon is equal to 0. The formal charge of nitrogen is equal to 0. Then I will see that this one has negative. This one actually doesn't need oxygen or carbon because it's already less. So it is -1 while this one is 0. So this is the correct choice. This is the more stable one. But what happens if I look at two of them and found that the total is equal to -1 or 0? Then I will look, Mr. This one is -1 and this one is -1. If I calculate and find it 1, then look, this oxygen here is -1, but oxygen here is 0. So which one you will pick? You will pick the one in which the more electronegative atom has a less formal charge. So it will be oxygen. So the structure that has oxygen with the lower negative charge. So in a just one-line tip, always give the negative formal charge to the atom that loves electrons the most. If you have fluorine, if you have oxygen, if you have nitrogen, but never give it to the carbon. Okay. If I want to see a practice question, what is the formal charge of nitrogen in NH4 plus? Can you try to calculate it? NH4 plus, what is the formal charge? Everybody in his mind, NH4 plus. Can you find it out? Then I will just show the answer. So the valency bonds of the nitrogen is 5. So I'll find the answer here. The valency electrons are 5, the bonds are 4, and the lone pairs are 0. The nitrogen, take care, this is not ammonia, this is ammonium ion. So it is linked to how many? It's linked to 4. So 1, 2, 3, 4, and there is a positive here. So this one has 4 bonds and has no lone pairs. So it will be 5 minus 0 minus 4. And then I will say it is plus 1. So the value is equal to plus 1. Okay. Let's see a different topic here from the topics that the students usually ask about or they fail sometimes. The limiting reactant determination. Okay. For the people who are studying, Bismillah ar-Rahman ar-Rahim, I think this is getting the review. So I think this has to be saved. Let me just save it for a moment. So the second one is the limiting reagent rescue plan. So what is the limiting reagent? For those who are taking too much time to study the stoichiometry, for them this one actually will be a very, very easy topic. Why it will be a very easy topic? Because they have done this long years ago, from year 9 or year 10 or grade 9 or grade 10, they are doing this. But for some students, actually, this is somehow a vague concept. Well, most of the people will tell me, Mr., this is very easy. Just let's have a look. The limiting reactant is the reactant that gets used up first. So it limits how much product is formed, which means that if I have more of it, the reaction would have proceeded to the products in more. So instead of getting 1 kilogram from the product, I will be getting more, 2 kilograms, 3 kilograms. Why did you stop? Why did you stop and you did not make more? I did not make more because I didn't have more of this limiting reagent. So if I have reactant A and reactant B reacting together, and this one is the limiting, and it contains, let's say, 1 gram, Mister, I was not able to make more than 1 kilogram in the product because this one is depleted or finished. So the limiting reagent, reactant is the reactant that gets up used first. It limits how much product is formed. The step 1 in order to form the limiting reagent is to change anything in the moles. Mister, that's very easy. Take care not to make a mistake. Some students will always say, Mister, this is 5 grams and this is 10 grams. So this is limiting reagent. For God's sake, is this possible? Can you just compare the masses like that? Where is the number of moles? You cannot compare the limiting reagent without looking at the number of moles. So step number one, change everything into moles. So divide the mass by the molar mass to get the number of moles, and then you can compare which one is smaller. But Mr., is there another step that I have to do before comparing them? The top mistakes to avoid is divide by the coefficient, Mr. Divide by the coefficient, and this is where the mistake usually happens. A, Mr. 2A plus 3B give me C. What is the number of moles? Mass over molar mass, and compare. Mass over molar mass, and compare which one is bigger, which one is smaller, or they are equal. Mr., if you did like that and you compared here, it's mistake. You have to first divide by the coefficient. Where is the coefficient here? This is the coefficient. This is 2. This is 3. So divide the number of moles that you got here by 2. Then divide this one by 3. Now only you can compare. Don't forget, in 100 students that are answering this, 50 of them will forget to divide by the molar mass. Then divide by the coefficient. Okay, take care. Some things which you know very well, and you are used to, you might forget in the exam during the heat of the exam. So don't forget to divide by the coefficient, and then after that things will be easy, because you will just see the smaller answer is the limiting reagent, and that's it. Don't forget, comparing the grams directly instead of converting moles, big mistake, big no. Forgetting to divide by the balanced equation coefficient, big no. Don't forget, the coefficient is the number which is before my substance. Number 3, using excess reactant as the limiting one. Mister, am I crazy? No, you are not. But take care, because you might be confused. After finding the limiting agent, you just pick up the other one by mistake. Yes, you say HCl and Mg. This is the limiting reagent, and you know it is the limiting reagent. Then by mistake, you multiply by the HCl. Oh my God, after calculation, you will forget. Yeah, sometimes it happens. So this is what's called rescue. This is what's called rescue. Rescue means take care. Don't make mistakes in the exam, which you usually don't make in the exam. If you are not used to exam, if you are not using to answering full exam, you will find yourself doing things that you do. That's why you have to count in your hand. Number 1, I compare changing grams into moles. Number 2, I divided by the coefficient. Number 3, I really picked the one which I said limiting reagent, and not by mistake I forgot and multiplied by the excess instead. So if I have 5 moles of hydrogen react with 2 moles of oxygen in this equation, what is my equation? 2H2 plus O2 divided to give me 2H2O. What should I do to find what is the limiting reagent? Like if I am asked to find the mass here, I must multiply by the limiting reagent. So how many moles? I have moles. Thanks God, 2 moles. No, 5 moles. And this is react with 2 moles. Do I need to make step number 1? No, alhamdulillah, he did it for me. Okay, at least don't forget the second step. What is the second step? Divided by the coefficient. So what happens if you don't divide by the coefficient? This one will be bigger than this one. For your luck, if you forget here, it will be 2.5 and 2. So this one is still correct. So you forget to divide, but you are lucky enough. But this doesn't happen every time. Sometimes after division, suddenly this one becomes bigger. Like if this one was 3, which one you will pick if you forget to divide? If you forget to divide, this will be 3. So you will say 5 is bigger than 3. No, but if you divide this by 2, it will become 2.5, and this is 3. In this case, the oxygen will be the bigger number of moles. So in our example here, if after I divided in our example here, it is 2 and 5. 2.5 is still bigger than 2, but you might not be lucky like that every time. So the limiting reagent is oxygen is the limiting reagent, because it's only 2 moles, while this one is 2.5 moles. So this is the smaller one. So this is the smaller one, and this is the limiting reagent. Okay, so let's go for number 3. What is the third point? That's a question sometimes might trick you in the exam. especially if you are a very good student. Even very good students sometimes make such mistakes. So be careful. You don't want to lose marks in silly things like that. This is the Le Chatelier principle. I think there is a problem in the link. Let me just update the link 1 second. So that's called the Le Chatelier principle application. So Le Chatelier principle applications, and it's here. Okay, let's see the Le Chatelier principle rescue plan. That's very easy, Mr. If a stress is applied to a system at equilibrium, the system shifts to minimize that stress. So add, you shift away. Remove, you shift forward. If I added some concentration to my A, I have A reacting with B. Give me C. Did you add anything to the A? Yes. Oh, system needs to decrease this amount because I have increased it, so it shifts away from it. But if I decreased it, if I removed some of the C, the system will try to make more of the C to balance that. So it will shift towards the C. So add, shift away, remove, shift forward, and think the balance and think the pressure. Where is the common stress scenarios? Adding or removing a reactant or product, changing the temperature. Mister, if you change the temperature, the system will try to make the opposite effect. But first, you have to check the reaction is exo or endo. Let's say this is an exothermic reaction, A plus B. Why say A plus B? We have the famous equation, N2 plus H2 give us NH3. How many times did you see this equation this year? So you have increased the temperature. The system will try to decreasing temperature. Where does decreasing the temperature happens? In the endothermic direction. Where is the endothermic direction? In the backward, because forward is the exo. So what happens? Hydrogen concentration increases or pressure, and nitrogen pressure increases. What happens to the ammonia? It decreases. What if I decrease the temperature? The system will try to increase the temperature. Where is increasing temperature happens? In the exothermic direction. If it is going here in the exothermic direction, which means increasing, which means it is already forward. What about changing pressure? Oh, this is much easier, mister. If you increase the pressure, the system will try to decrease the pressure. So where does decreasing the pressure happens? In the direction of less moles or more moles? Less moles. Take care. This is only of gases. Where does the mistake happen, yeah, mister? 90% of the students know this. 90% of the students know this. But look at this tricky part. Calcium carbonate changes to form calcium oxide plus carbon dioxide. The famous trick. Huh? Mister, where is the number of moles more? On the right or on the left? On the right, of course, it is more moles. Yes, because it is how many moles? One and solid and solid. Hey, did you calculate the number of moles of the solid? Oh, this is only in pressure. So don't calculate this. Don't calculate this. There is only one mole on the right side and there is no moles on the left side. What if I increase the pressure? The system will try to decrease. So it will move to less moles. Here 1 mole, here 0 moles. So it will move left. What if I decrease the pressure? If you decrease the pressure, system will try to increase the pressure. So it will move in the direction of more moles, which is 1 mole, which is to the right. Let's try to make a check. In this equilibrium, what happens if H2 is removed? This is the easiest one, mister. If the H2 is removed, the system will try to increase it. So it will move to the left. What happens if you move to the left? The system shifts left to produce more H2. So as we said, if you add, you will shift away from it. If you remove it, you will shift towards it. So it shifts towards the hydrogen by going backward and making more of the hydrogen and more of the nitrogen. Let's fix this. Let's fix this one also. Let's fix this one. There was a link issue here. Yeah, here is a mistake, wrong link here. Okay, updated. Okay, let's see where is the next one. The next one, Mr. Eric, the buffer capacity and pH calculations. Let's see if this is correct. With links, yes, Mr. The Henderson-Hasselbalch equations that everybody hates. pH is equal to pKa plus log the salt over the acid. No, I don't like salt. The conjugate base over the acid. The concentration of the conjugate base over the concentration of the weak acid. The buffer resists pH change strongest when the concentration of A minus the conjugate base is more than HA. The pH is equal to the pKa. Mister, what is the point in which the pH is the pKa? pH is equal to pKa. What do I call this? Is this equivalence or is this half equivalence? What do we call it? pH is equal to pKa. Huh? What is that? pH is equal to pKa. What is that? Is this equivalence or half equivalence? Anybody? So when the concentrations of pH is equal to pKa, this is the half equivalence. This is the point at which the conjugate base concentration equal to the weak acid concentration. So this is the buffer working. The pH cannot change or increase or decrease. Type. What affects the buffer capacity? What is the buffer capacity? Everybody knows what is the buffer. Everybody knows how to make the buffer. Everybody knows what the buffer do when the acid is added or when the base is added. But do you know how strong is your buffer? Can the buffer resist big amounts? This is called the buffer capacity. The buffer capacity is the part that everyone is weak at. Buffer capacity means how much the buffer can resist. Can you add 1 liter of a strong acid? Can you add 5 liters of a strong base? Until which moment the buffer is going to stand and withstand before it breaks and it cannot resist the change anymore. This is the buffer capacity. When you have higher concentrations, you will have higher capacity. So the range of the pKa is usually plus or minus 1 range. So plus or minus 1 range. If you add strong acid or strong base, this makes something called buffer overload. Buffer overload means you are adding the H plus or H minus very fast, so you cannot expect the buffer to work. If pKa is equal to 4.74 and A minus over HA is equal to 10, what is the pH? Mister, what an easy question. Just use the equation. The equation says pH is equal to pKa plus log A minus over HA. So the pH is equal to 4.74, and this is log 10, the concentration of the weak acid of the conjugate base over the weak acid equal to log of 10. So 4.74 minus 1, so plus 1 equal to 5.74. Means that the pH of this solution is 5.74. Don't forget the opposite of this equation. If you are looking at pOH, so if you are looking pOH, the equation reverses. It becomes pKp and then log of the conjugate acid over the weak base. Don't confuse these two equations with each other. And don't forget the relationship between the pKa and pKp. You are going to need this a lot in the exam. I'm expecting to get a question about this here because many questions are coming about this one, pKa and pKp. Do you know what is the relation between pKa and pKp? Find the relationship so you can find the other one if you have one of them. If you have pKa, make sure that you know how to get the pKp. If you know What's PKP? Make sure you know how to get the pKa. This is expected this year to come. They are stressing too much on this point these days. Okay, so let's have a look at the next part, which might be a little bit confusing. And we are still on the 10 top AP chemistry micro questions. The students Google or search on the social media or in Reddit or in the websites. So let's have a look at the electrochemical cell notation. This is also a part which most of the students will skip while studying. Most of the people will go and search for electrolysis. How I can find the products of electrolysis? Mister, how can I make the electrochemical or galvanic cell? What is the salt bridge? What is the benefit of the salt bridge? Then everybody goes and says, oh, electrochemical cell notation, that's very easy. Most probably I'll be able to do this in no time in the exam. But guess, you might lose a very easy mark if you don't take care. In electrochemical cell notation, you put the anode, then the anode solution, concentration, and then the two lines. The two lines is representing what? Our salt bridge. Don't forget, this is what is representing our salt bridge. And then the cathode solution, and then concentrated, and then the cathode. Take care. If you have a solution and you don't have a metal, what you should put at the end here? Huh? Anybody knows what is the thing that you should put if you have a solution and you don't have a metal? Platinum. Don't forget to put your platinum here if you are in the cathode and your platinum here if you are in the anode. That is if you don't have a metal. But if you already have a metal, then copper will be enough. Why do you want to put a platinum? In case of gases and in case of solutions, please, 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 3 times, please, 100 times, don't forget the platinum. Everybody is doing everything correctly. Writes down the Fe and the Fe plus. Tell me the Fe plus is oxidized from Fe plus 2 into Fe plus 3 or the opposite, and then forgets to put the platinum here. Don't forget the platinum. This is the electrode. You should write the electrode if it is a solution or the gas. Also, if you have hydrogen, don't forget to do the same. The hydrogen is reduced. It changes from H into H plus into H2. And when this happens, there must be a platinum. This is your electrode, so don't forget it. Okay, this is the rules that you must follow. Always write the anode on the left. Mister, this is a single line which is phase boundary between the thing that is oxidized before and after, and the thing that is reduced before and after. So this is the line. This is the line that represents what's happening. And this line also, difference between what is reduced and after reduction in the cathode. And this line is the salt bridge. The double line is the salt bridge. Left side is oxidation, right side is the reduction. Mister, always write the anode oxidation on the left. Use dash between different phases, solid and aqueous, or aqueous and solid. Use the double dash to indicate the salt bridge. Inert electrodes, platinum or copper, are used if no solid is present. Please don't forget. لو ما عندكش solid, if you don't have a solid electrode, you must put the platinum or the carbon or whatever electrode you have used. I recommend using the platinum for sure, easier and the most famous one. Sample notation, the cell is made from zinc, which has been oxidized into Zn2+. So this is the oxidation. This is where the oxidation happens. The zinc has been oxidized into Zn2+. So I write Zn solid. Don't forget, this is not optional to write. The solid physical state is not optional. Don't think that you can write it or not. You must write it. And that the Zn2+. So this is oxidized by losing electrons. Its oxidation number has decreased. It has lost 2 electrons. Again, the aqueous is not optional. You don't have the option to write it or no. 1 molar, and then you put copper 2+. The copper is reduced by changing into the copper solid by gaining electrons. This is the aqueous form, and this is the solid form. Another trick is to put the concentration. Actually, I prefer if you put the aqueous, because I don't want you to tell 1 molar and then the solution is not 1 molar. Then you will come and ask me, Mister, you tricked me. He put 0.1 solution and asked me to put it. So I prefer you to put aqueous only, don't put the number unless you are sure 100%. That's why I prefer, if you put aqueous, he will give you the full mark. I don't want you to say 1, because 1 only is if there is standard conditions. But what if there is no standard conditions? What you are going to do? So where is the anode, mister? The anode is the left one for sure. The zinc is the anode. This is the one on the left side. This is the oxidation that's changed from the zinc into Zn2 plus. Okay, that you looking easy. And what is the next one? Endothermic versus exothermic. Mister, I'm in AP chemistry in grade 12 and you are asking me about exo and endo. Let's see. This is questions with the students ask. Release heat, delta H is negative, feels hot. Feels hot. This is where the mistake comes. Everybody knows endothermic. Everybody knows exothermic. The tricky mistake, feels hot. Temperature increase. Please, please don't make this silly mistake. Mister, I won't. Endothermic absorbs heat. Everybody thinks, I'm absorbing heat, so my temperature rises. Please, come on. If you absorbed heat, you took it from the outer source, and this is where the thermometer. So please don't think that absorbing heat makes your temperature increases. It's the opposite. What is our most famous example? The most famous example is combustion. Don't forget, if you get confused in the exam, exothermic, most famous example, combustion. The temperature increases. Can anybody tell me that the temperature decreases in exothermic? No. Can you sit behind a fire and feel cold? No. Why? Because it releases the heat to the surroundings. That's why you feel hot. What about if you have a back pain? You go to the back pain and you put an ice pack. What happens to the ice pack? The ice pack, what does the ice pack do? It absorbs heat from your body. It absorbs heat from your body. So your body is the surroundings. Although it absorbs heat, it feels cold. Why? The batch itself temperature increases, but your body temperature decreases. That's why your body feels cold. If you never saw an ice pack, go and buy one from the pharmacy. Now you can go and then you have an ice pack. It looks normal. Then once you crush it in your hands, suddenly it becomes cold. And before you crushing it, it's not cold. It's very nice thing that when you just crush it, it becomes cold and you put it in your pack if you have back pain. But unfortunately, this can be done one time. It's not reusable. So once it's crushed, you cannot use it again. Okay, so think exo, exit heat, endo, enter heat, track energy flow. Better than tracking energy flow, what is a 1 second trick that will help you in the exam? Remember the famous example. Exothermic, combustion, feels hot. Quick check, let's see. Is dissolving ammonium nitrate in water endothermic or exothermic? One of the fewest examples about endothermic reactions is the ammonium nitrate. Make sure that you know this. Not all of the students know it. Actually, like 10 or 20% only of the students know that ammonium nitrate dissolving in water is endothermic. Come on, the examples for endothermic in chemistry and in life is very few examples. We have like calcium carbonate, breaks down into calcium oxide and carbon dioxide, and dissolving of ammonium nitrate inside water. If you change it from solid into aqueous, this is endo and this endo. These two are very famous endothermic reactions. You must memorize them. Okay, so what is the next point? That some of the students, even the very, very good ones, might make mistake in the exam in hybridization and molecular geometry. Oh, that's not every one make mistake, because Mister, I have memorized it, and Master, it's good for you. Count the regions of electron density around the central atom. If you have two regions around it, so C around it 1 and 1, it's two regions, so it is just SP. If it is three regions, like C, like N, like C, like O and H, how many regions are there? Are there 1 or 2, yeah, Mister? Or 3, 1 and 2. Somebody will tell me it is 3, 4. So this is 3, 4. So this is 4 minus 1 is SP3. But I need an example. I need an example for SP2. Anybody give me an example about SP2? Anybody give me an example about SP2? How many things around it? BF3, mister, I have three electron clouds. 1, 2, 3. When you subtract 3 minus 1, you get 2, so it is sp2. Mister, if you want to be يعني extra knowledgeable, 5 give me sp3d, 6 give me sp3d. If you want to memorize this, it's an extra information. If not, then rest assured that it has never been asked before. And I don't want you to, sorry, not you to know only the sp32, the sp2, and the sp. That's more than enough. But if you want to know that this is octahedral, it's good for you. Why? Because if you didn't take it this year, the biochemistry teacher is going to ask you about it in the first year of the college. So don't tell that I didn't tell you. sp3 D2 is octahedral and it's 90 degrees. It's very famous structure in transition elements and in organic compounds. So most probably in the first year in college, they're going to ask you about it in the biochemistry if you will take it. But other than that, I need you to memorize the first four at least. sp is linear 180. sp2 is trigonal planar 120 degrees. sp3 is tetrahedral 109.5. sp3d is trigonal pyramidal 90 and 120 degrees. And if you don't have the file for the full thing with the full angles, just tell me, because I'm going to send you plus the gift that I'm going to send it at the end of the lesson. What is the hybridization of the central atom in CO2? Mr. CO2 has what around it? It has CO2, two electron clouds, 1 and 2. Is there anybody who will tell me that these are 4? Can we make this mistake now? If you don't know, then these are only 2 electron clouds, not 4. This is counted as 1. 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 Take care. It is still called 1 electron cloud. So I have 2 electron clouds, so it is sp. The lone pair matters. Don't think that the lone pairs is not counted. Of course it is counted. So O, H, and H. Should I count this one and say it's sp? No, this has 2 electron clouds again. So this is 1, 2, 3, and 4. So 4 minus 1 is sp3. It might be a pent or trigonal pyramidal. It depends on the number of lone pairs. So if there are 2 lone pairs, then it is bent. If it is trigonal pyramidal, if there is only 1 lone pair and 3 lone pairs, it's going to be trigonal pyramidal. Again, for the students who don't have the full list of angles and hybridization and the shapes of molecules, make sure that you already memorized them. Or if you don't have it, then just ask me and I will send you the full list. Okay, what is the geometry of NH3 based on the hybridization? For sure, NH3, we just said that it has 3 bond pairs and 1 lone pair. It's trigonal pyramidal, 1 lone pair only, not 2 like the water. So it is 100 and is it tetrahedral? No. It's trigonal pyramidal? No. If it is linear? No. What is the angle of the pyramidal? What is anybody? What is the angle of pyramidal? I'll be waiting for you to answer. Okay. And this one was number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 6 and 7, and we'll continue the rest after our first short break. We'll take 5-minute break, take some water, and then come back. Our break is finished. Let's have a look at the three remaining parts here. Yeah. The three remaining parts, it's interpreting the mass spectrometry data. And the big idea is that I have an x-axis. So most of the students also, if you ask them what is in the x-axis, they will be a little bit confused. Mister, I know here that there is a relative abundance. So this is how many isotopes or how many peaks are there. So I know that if there is 70%, it will be here. If there is 10%, it will be here. If it's 10%, it will be here. So I can total these two all percentages and it will be 100%. But what is there on the x-axis? On the x-axis, you have the ratio between the mass to the charge. The mass to the charge. And since the charge is always almost the same, then you are actually talking about the mass all the time. Since the charge will be almost the same of the particles measured by the spectrometry, then, or the spectrometer, then you are basically talking about the mass. So if you compare the x-axis to the y-axis, you will get the mass to the charge to the relative abundance. So because this is a topic from Unit 1 and very old topic, so most of the students will forget to answer questions about this one. So please, I encourage you to go and answer as much as you can questions about the questions on the spectrum, because this is one of the points that sometimes they can get new ideas in. You have to master it very well. You have to make sure that you know how to measure the relative abundance if you are giving the average mass, or if you are giving the average mass and you want to find the relative abundance, you can get this one also by making a one common unknown like an x, and then the other one will be 100 minus x. So the highest m over z p is the m plus. This is the molecular weight. The smaller peaks are the fragments, and this one doesn't come actually a lot in the exams about the fragments. So we'll just stop here at the definition of the xy axis, and then we'll just get to the next point. If you were asked about the M plus, and this one also never came before in such exam, but just for your knowledge, what is the M plus? This is the biggest peak, and this will tell me what is the molecular weight or the molecular mass of the substance that I'm measuring. So, for example, if I am talking about CH3COOH on the graph X Y. On the x-axis, what is showing here is the mass of the CH3 COH. Why? Because here you will remove one electron, you will have a positive charge, and the mass of the electron is negligible mass. That's why actually after removing electron, you will be having the same mass of the substance. So the peak that you see here on the spectrometer is actually the mass of the substance that you have. The next one is the net ionic equation. So the net ionic equation is also a very easy part. Please, I encourage you to try to make a little bit practice on that so you don't miss this easy question. And the point is that I'm getting this one in the exam is that this is one of the parts that they like too much. They like this part too much. And the examiners always like to every 1 or 2 every 2 years at least they will put one question about the net ionic equations, and it will be really sorry if you miss a mark from this one. The point is usually the question contains many parts and you need to make them all correctly so that you can get the correct mark, especially if it is 1 mark. Then you are asked to make the correct product at the end, make the correct reactants, the predominant reactants only, cancel out all the spectator ions, and make the physical states correctly. And what is a little bit difficult thing is to get them all correct. Because some of the students will make them correct, but then forget to make the physical state or write the physical state in a wrong way. If you forget, the spectator ions will be only left, and these one are the things that change its physical state. So if they are aqueous in the product, they become solid in the. If they are aqueous in the reactants, they become solid in the product. But the thing is that remain the same, like if you are equal from the beginning and equal at the end, then nothing has changed in your physical state. Then you must be cancelled because you are a spectator ion. You are just watching. We have three types of net ionic equations. Please focus here. Three types that always come in the exam. The precipitation reaction one,
And this case, you will write the product, make it as solid, and write the ions that's forming it, aqueous and aqueous. The second one is the neutralization reaction. And what a pity, most of the students will fail here, will fall, and they will still hear this question. Everybody should know that NaOH plus HCl is a neutralization reaction. Please don't go and write Na plus and OH minus and H plus and Cl minus. And I'm very sad when I see the students writing to me that it is H plus and OH minus, and then it has Na plus and Cl minus, and leave the equation like that. So most of the students will be looking for the solid, and when they find that they are, because they are used only for answering the precipitation one, but when they are faced with this equation, they will be a little bit confused. Unless you know already that for neutralization reaction, all you need to write is H plus and OH minus, give me H2O. This is liquid. Don't ever break the liquid or solid into ions, aqueous and aqueous. Any neutralization reaction, H plus and OH minus, give me H2O. This is all that you are required to write. Na is aqueous into aqueous, and we said anything that you did not change will stay the same. And Cl minus and Cl minus are both aqueous also. They don't change. So anything that don't change, cancel it out. So you are left over with this only three things to write, and don't forget the physical state. Anything that's liquid, anything that's solid is never written here. Mister, the most difficult one, it's not difficult, it is just not very common. That's why most of the students also will get confused. And if I am asked to write the net ionic equation for this reaction, if sodium carbonate reacts with HCl to form NaCl, and then H2O and CO2 gas. Here, it's a little bit also easy, but some of the students will fall here. So the student will be confused. Mister, I don't have a solid, so it's not a precipitation. Okay, so what is that? Ah, it is an acid and a base. Mister told me that if there is an acid and base, write water and the ions. So they will go and write water and H plus and OH minus. This is what Mr. Hisham told me. He told me to write the H plus and OH minus to form H2O. Ah, unfortunately, you missed something. This is correct only if you don't have a gas. This is correct only if you don't have a gas. If you have a gas, there are ions which form this gas that you must write down. So let's see what did change its physical state. Na plus is solid and CO3 is solid. So, Mister, if I dissolve this in water, it will be aqueous sodium carbonate. So, basically, this does not change. Basically, this does not change. If you have a gas inside the neutralization reaction, here is what you need to do. You need to write the water and the gas. Don't forget, if it is a neutralization reaction without a gas, write only the water. If it is a neutralization reaction and there is a gas produced, is it CO2? Is it H2? Is it SO2? Then you have to write the water and the gas, not only the water. And what are the ions that form the water? Then cancel only the salt. So Na plus and Cl are all cancelled out. And you are left with CO3 2 plus and H plus. Take care. If you are making a net ionic equation, you have a liquid and gas produced. The liquid is here, gas is here. And what is the reactance? CO3 2 minus plus 2H plus. What does it form? Don't forget the balancing. Don't forget the balancing. So it forms the H2O and CO2. Okay, again, I'm saying it. That ionic equation is a very easy thing. You have three types. Precipitation is number one. Neutralization in which there is water only number two. And neutralization in which there is a gas. You must mention that this is a gas, this is liquid, and these are the two ions that form it. This one actually dissolves and forms water. So even if you started with a solid, it changes into an aqueous solution, but then it is changed into a gas. So since it changed from the aqueous into gas, it's gonna stay here. So why it is a difficult question? It's not difficult. It is very easy. The problem is that you have to write the balance, the correct product, the correct reactant, and the physical state. You have to do this all correct in order to get 1 or 2 marks. Okay, so the quick practice is NaOH plus HCl give me NaCl plus H2O. I bet this is very easy now. Show answer shown just that it is H2H plus and H minus give me H2O. So whatever, write the balanced equation, split the aqueous compounds into ions, cancel out spectator ions, rewrite what's left. That's the net ionic equation. And the last thing that we have today is choosing the right indicator for the titration. Again, this is a point that is a little bit confusing, although it is a very easy. Okay, but why, Mr. It is confusing? Let me tell you the truth. As a teacher for a long time, usually the things that are at the end of any unit is the thing that the students usually fill in. يعني إيه يا Mr. يعني you have unit 9. The student keeps studying and studying and studying and studying and studying and studying and studying, and then at the end of the unit, he is very tired. If there is equation, Nernst equation, he will hardly memorize it. If there is electrolysis or electroplating at the end, Mister, I get too tired, then I miss this part. And then unit 8, the students keep studying the acid-base equilibrium, the pH, the buffers. He answers 100 questions on the buffers. He look at the titration curves. And then when he is sure to press, when it is almost done, he finds the titration curves, the indicators. And then he thinks, oh my God, I'm already run out of battery. Let's see this next time. And then this keeps repeating. That's why it is difficult. So it's not difficult, it's only at the end of the unit. Please take care. This is very important point. Take care of things which are at the end of the unit. This is the part at which most of the examiners will ask because they know that by the time you reach the end of the unit, you are usually very lazy, don't want to continue. So what is there? Strong base, strong acid, the pH is equal to 7. Without thinking, use phenolphthalein or bromocymol blue. I will recommend the phenolphthalein. But بالك, take care. This is usually very confusing because the phenolphthalein is a little bit different from the pH, is a little bit higher than the 7. So if you are not used to it, if you have never tried it, then you will be confused. But like, if you answered at least 1 or 2 questions on the indicators, you will know very well that the pH 7 is the phenolphthalein, no thinking. Strong base and strong and weak acid, the pH is less than 7. We will use the methyl orange. Weak acid and strong base, pH is more than 7. Use phenolphthalein. Weak acid and weak base, this is no sharp change. There is never a good indicator to cover this. Why, Mister? Because the change is like that. It's happening in the second. This vertical part is almost not there or very small vertical part, not like the other curves where there is a big vertical part. So Mister, I'm gonna memorize this one. I never said memorize. I said you have to look at the table, the numbers that you have, but put this in your mind. Please, everyone, put these names in your mind because if you are confused, you will return back to them. If you look at the numbers and look at the vertical part and look, see that the numbers is confusing from the vertical part, then pH 7 use phenolphthalein. pH less than 7 use methyl orange. pH more than 7 use phenolphthalein. This one has no sharp change, so no good indicator. Which indicator will be best for using HCl with NaOH? Again, don't memorize this. It has only to be known according to the numbers. يعني يا مستر, he will give you phenolphthalein is 8.3 ل 10 and I need to make it 7. عرفت ليه انا بقول لك it's a little bit confusing because if you did not answer this before, you will be confused. This is 7. The closest one is what? The phenolphthalein. What about less than 7? You are going to something low, like 3.1 to 4.4, the methyl orange. The bromocymol blue is 6 to 7.6, which is usually used for 7 indicators like the 7 pH 7.1, like the bromocymol blue when I use it with the strong acid and strong base. So the target practice to do is you have titration acetic acid, weak acid with strong sodium hydroxide. Which indicator I'm gonna use? Mr. The weak acid with the strong sodium hydroxide. Of course, it's gonna give me the table. عمره ما هيقول لي احفظ الارقام في الامتحان. It's gonna give me the table and I will see It is endpoint is slightly basic, about 7. So my first choice is phenolphthalein, of course. Okay, that was the end of it. 10 of the most asked questions or the most missed questions or points in the AP chemistry exam. And I hope that you get benefit from this one. And in the next time, inshallah, we are going to see the hard topics check. If you are lost, if you feel lost in one topic, so please go fast to this part. It's very good. The hard topic check help you know. Yani, Mr. I'm sitting and I don't know. I feel bad about unit 8. I feel bad about unit 7. Then go to the hard topics check. Mr. I feel very bad about unit 1. I feel very bad about equilibrium. I don't trust myself in kinetics. I don't trust myself in electrochemistry. Then go and press electrochemistry. Oh my God, I'm gonna go and see some of the questions. What is the function of salt bridge? Oh, Mr. This is balances charges by ion flow. In a redox reaction, oxidation is defined as loss of protons. Oh, no, loss of electrons. So that will be made as wrong. Of course, it is loss of electrons. What does oxidation occur? It occurs in the anode. If you said in the salt bridge, it will be, of course, it is the anode. What is the standard cell potential? The standard cell potential is the sum of reduction potentials. No, is it the standard cell potential is the cathode and the anode? That's where you find the number. I think there is some error in this one coding. I will just try to fix it today. This to determine if the cell is spontaneous or not, and it is the difference between the cathode and the anode. I'm gonna fix this one today. So, Mr. If I feel a little bit confused about delta G, delta H, delta S, you will find some questions also. This will give you some power so that you can go and, oh, Mr. I'm not that bad. I can answer, I can get a mark, and guess what? At the end, you will get a nice report. So if you did this right, and I'm just picking anything, we'll see this next time together. And then you see what's a nice thing in this one is that after you are finishing here, you will get a nice report which tell you your score and tell you what you need to focus on. So you have to focus the delta H is a chemical reaction. You missed that delta H is more than 0 and delta S is more than 0, less than 0. So delta G is what? So it will give you an idea about what are the things that you need to focus on. Then after finishing this, we will be a little bit less suspecting of yourself. And there is also the exam check month. So this one also we will see the next time, inshallah. Okay. Thank you so much for your time.